Hi everyone. My name is Moustafa Naiem, and I'm the founder and CEO of Resilio Climate Solutions. A bit of a background about myself. So I finished my PhD in climate resilience at McMaster University here in Canada. And during my time, I went to the University of Cambridge and I stayed there for 7 months, working with the Center for Smart Infrastructure and Construction and in affiliation with the Center for Digital Great Britain, where I got introduced into the nitty-gritty details of digital twin technologies and the different applications that we can use in climate resilience and adaptation. Once I finished, I went back to Canada and I started working with KPMG's global infrastructure practice as a climate adaptation and resilience expert. I worked there for like a year and a bit, and then I saw the huge gap between what we know how to do in the research community and being developed with the cool tools that we know and what's being applied in the public sector and how there's a huge need for informed decision making for proper or not proper, but I mean more comprehensive infrastructure management. Um, so I left my job at KPMG and I went back to the research space as a research associate at the University of Western Ontario, and I founded Resilio Climate Solutions. I'm not sure if the slides are moving for some reason; it's a bit lagging there, but just let me know if once it starts moving. Yeah. So Resilient Climate Solutions, we envision a future where like infrastructure stakeholders can leverage proper AI tools and digital twin technologies to make informed decision, reduce costs, and optimize spending on infrastructure management. Our mission is to utilize and employ those advanced tools to provide actionable climate resilience insights, and we aim to empower communities and organizations to proactively mitigate the impact of those extreme weather events to ensure a sustainable future for everyone involved. Now, the application for climate risk tool prediction and so on are applicable in many industries, but my focus here is on the use cases that we've developed for the public sector and for proper infrastructure management for the betterment of the lives of those who live in our communities and the public infrastructure. So there are a few quotes that usually resonate with me. And the first one is that the fight against climate change is hijacked by the race to net zero. There isn't the same amount of attention and spending, at least, being poured into climate adaptation and efforts for a lot of reasons. Uh, People are very preoccupied with trying to prevent a worse future, but where we are right now is pretty bad enough. So when I was like from personal experiences and this kind of informed doing this, when I was in the UK, there was an extreme heat event that happened in the summer of 22. I had a flight and I needed to go from Cambridge to Heathrow Airport, and the transport infrastructure was entirely crippled because of that extreme heat dome that was in effect at the time. I missed my flights, and a lot of people were inconvenienced, and there was a mess over there. And this kind of like informed my drive to kind of push towards using those technologies for making better informed decisions on the management of our infrastructure. A couple of weeks ago, a similar extreme flood happened in the city of Toronto, where I live, and most of our infrastructure was crippled for a few days, and people were left without power for over 16 hours. And in this day and age, I think that this is widely unacceptable given how we know about these advanced technologies and the use cases for those applications. Last year alone, there were over 28 events that crossed the $1 billion in damage in the continental US alone. And in North America and especially in Canada, 87% of Canadians live in urban centers where their infrastructure is extremely interdependent, and cascading failures can happen and cripple the lives of all of those people. So what do we do? Well, we have developed a methodology that is divided into two modules. The first one is climate risk assessment, which is kind of a prediction of future extreme weather events, and then a digital twin module to visualize and quantify the impact of those damage, and then get return on investment for adaptation or get insights into how to better manage our critical infrastructure so that we can keep the community functional during those extreme weather events. The hazards that we're looking at are flooding by its different types, wildfires, extreme heats, and tornadoes. We already developed the capabilities for the floods and the extreme heat. Wildfires is currently under development, and tornadoes and cyclones is in the far future. So we haven't really gotten into that one yet, but it's in the docket. So our methodology is that we integrate climate models with a lot of AI components, especially deep learning, to kind of predict extreme weather events with high accuracy that, as they might happen in the future. And then we plug that into a physics-based modeling platform that we also developed or using tools to develop. Um, with attached something called machine learning synchronization, which kind of accurately translates the hazard realization into the damage quantification for the proper infrastructure functionality embedded within our systems. Uh, the way we change the climate risk into damage quantification is kind of dependent on the type of infrastructure we're looking at. So if we're looking at physical infrastructure like buildings and assets, we start using damage stage curves, which are a form of fragility functions that allow us to quantify the physical climate risk from those extreme weather events or those hazards that we're looking at. But if we're looking at more comprehensive look at the different infrastructure networks, then we start using and network analytics, whether that is for a single network or a network of networks, depending on the interdependence and the availability of data of the community we're looking at. But this also allows us to integrate or embed the criticality of certain assets or nodes or links within the networks. And this kind of gives us a better look at the cascading risks that might happen given those extreme weather events. And then we look at the resilience quantification, which is kind of the lay of the way, as we say, uh, the point of recovery, but we acknowledge that the process is entirely probabilistic. So the hazard realization is probabilistic, the damage is probabilistic, and the recovery is also probabilistic. So we started using resilience surfaces instead of resilience curves to quantify that, and we adopted resilience triangle methodology, as we say, and it's very robust because it gives us the capacity to do multiple scenario analyses on whether we do have mitigation measures or we don't, and whether the path to recovery is simple and straightforward, or do we have certain goals that we set along the way. And then we start mapping all of the information in our digital twin platform with climate data, but we also integrate vision climate models. The the regulations, the regional regulations for climate-related regulations, and then we embed hazard likelihood and characteristics with some of the socioeconomic properties of the community we're looking at, along with asset properties, location, the infrastructure conditions, and the infrastructure interdependence. All of that is then fed into our simulation platform where users can then look at the different scenarios that might happen to conduct what-if scenario analysis for different mitigation measures, and they can visualize the hazard intensity throughout different years, whether that in the year 2030, 40, or 50, and we translate that into vulnerability for the exposed assets and divide it based on certain likelihoods. Where people can then take a deeper look at the most vulnerable assets or the assets with the highest values. Another look is to translate all of that into risk, and from risk, we can translate it into damage and dollar value. And this is one of the use cases that we have for kind of getting return on investment for adaptation for the sea academy here in Canada. But another very useful use case is an early warning system. So we have developed one of the early studies that we did was an early warning system for the campus of McMaster University, where we can take on live precipitation data as they are being rolled out and assess the damage on our campuses, infrastructure, and the buildings, and so on. And we have our simulations were very accurate in terms of the exposure and the kind of it's dependent on the accuracy of the precipitation data, of course. But we were able to kind of get an early warning for one of the extreme flash floods that happened a few years back, and we were able to kind of put in mitigation measures pretty early and lessen the impact of those damages. Finally, the thing that we take pride in is that we are able to kind of focus on one critical infrastructure at a time if we want. And for this use case, we looked at the critical infrastructure needed for emergency response. So all the institutional buildings and the schools and all the buildings that are required for emergency response and evacuations. We took a look at the exposure and vulnerability of those exposed assets with the total value of exposed assets as well, and kind of an outlook of how their vulnerability changes over time and with the change of the hazard realization. I know I might be towards the end of my time here, so this slide is a brief kind of acknowledging on the publications that we have developed into this space and how we have formulated our methodology. Thank you.
So the first question to yourself is, do you think your work could be useful to the UK's climate resilience demonstrator, the CREDO project?
All right. Well, it can be, yes. We are looking. I've been following the CREDO project since it started, and I've been looking at the way that kind of you're focusing on specific infrastructure and the interdependence between kind of power network and water network and so on. We're kind of looking at a more comprehensive look from afar, but when we start integrating specific infrastructure network, something very similar to CREDO is what we are developing. So it can be very useful on the long run once you want to kind of once the CREDO project wants to take a more comprehensive look at the bigger picture. It can be integrated. Yeah.
Very good. And there's also a linked one here that's just appeared around the links to the Isle of Wight use case as well that's been done by the National Digital Twin Programme. So I don't know if there's any additional stuff you'd like to add on to that.
Okay. Can you say that again? Sorry.
There's a follow-on question that came through similarly saying that there could be really strong links to the Isle of Wight use case demonstrator being done by the National Digital Twin Programme.
Okay. I wasn't familiar with it, so I'll take a look at it then. Yeah.
That's good. Our next question here is, how do you think your approach could transfer to resilience of other types, not relating to climate?
Well, the methodology that we developed into the both modules for kind of hazard realization to damage quantification can be applicable on different hazards. Like for example, like we examined this for like I don't want to say like terrorist attack, but like bombings or cyber attacks on power infrastructure. So we kind of examined the application of the same methodology onto different kind of attacks or external stresses from the network, and it works. My personal kind of inclination is toward climate hazards, but the methodology does work in different settings as well.
Very good. Follow-up question here, if you could please, is what 3D base map solution are you using for your 3D map of buildings and infrastructure? Where do you source UK data from?
I haven't sourced UK data, so this was from a Canadian city that we had a working partnership with them, and also in Canada, there are most of this information, at least for building archetypes and locations and conditions, are public. So for Canada, it's a bit different than in the UK, where the UK things are very data driven and kind of security is a big issue. In Canada, it is, but I mean, there are more publicly available data, but we do work with data owners and like cities to kind of gauge the look and feel of those infrastructure assets. We've been using game engines and ArcGIS for our 3D simulations. We're working on developing our own platform to integrate all those tools in the same space. But for the demonstration that I did, we're using infrastructure platforms like I said, ArcGIS and so on.
Very good. Final two questions here is, what data does your digital twin hold relating to assets, resilient measures of each asset, and the things that affect how they respond in different weather events? What about the connectivity of assets and the cascading risks?
So for the assets themselves, our data is as detailed as the the data of the provider. So we have most of our backgrounds is from structural engineering, for example. So when we look at building, we take into account the structural conditions of all of those assets combined. For each building, at least we know the asset condition, the age, what kind of stressor, or like what's the extreme amount of external stress that the asset can hold, and we integrate that into our fragility functions, or the way we translate the hazard into risk or damage. The second question is, what about the connectivity of assets and cascading risk? Well, that's where network analytics kind of comes into play. That's why we integrate both approaches. And the network part is where the connectivity of assets and the cascading risk and asset criticality play a big role.
Very good. And the final question is, are you working with Infrastructure Ontario? They've just announced funding for digital twins in Toronto.
So I used to work in a team that kind of was informing the budget announcement, but right now I'm not working with them. Once I'm kind of had the enough traction, I'll reach out to them and see what we can do in that space. But I'm following the project, and I'm very familiar with what they're doing. Yeah.